Welcome viewers, in this video we will see the solved problem based on the torque equation of the DC motor. This is part 4. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the problem. A 4-pole 250 voltage DC shunt motor has a lap connected armature with 960 conductors. Flux per pole is 2 into 10 to the power minus 2 Weber. So, this problem based on the shunt motor. The winding is connected as lap connected. Calculate the armature torque TA and shaft torque TSH. We need to find the armature torque and shaft torque when current taken by the motor is 30 ampere. The armature resistance 0.12 ohm, field resistance, shunt field resistance 125 ohm. The rotational losses is 825 watts. So, now we will analyze what are the data available, what are the data given. The number of pole is given as 4 pole. The voltage is 250 voltage. The number of conductor Z is 960. The flux per pole is 2 into 10 to the power minus 2 Weber. The load current is 30 ampere. Armature resistance 0.12 ohm. Shunt field resistance 125 ohm. Rotational loss is 825 watts. We need to find the armature torque and shaft torque. It is lap connected, so the number of parallel path is equal to number of pole. Number of pole is 4, so that number of parallel path equal to P, that is equal to 4 because of lap connected. First we will find the armature torque. Armature torque is nothing but torque developed inside the motor. Useful, that is a total torque. For a shunt motor, IA equal to IL minus ISH. That is IL equal to IA plus ISH. From that, IA equal to IL minus ISH. Right? This IL is already given 30 ampere. So, this ISH is nothing but V divided by RSH. Because the field is connected in a shunt field, so that we can use the voltage. Load voltage can be used for finding the ISH, shunt field current. V by RSH, all are connected in parallel, field winding, armature and load. So, that same voltage is available across load as well as armature and field. So, that V divided by RSH. So, 250 divided by 125. So, 30 minus 250 minus divided by 125, that is 28 ampere. So, now we calculated the armature current because here armature current is needed. So, the armature torque equal to 0.159 pi Z IA into P by A, that is flux into number of conductors, armature current, number of pole and number of parallel path. So, all the data are available. IA also now we calculated. So, 0.159 into the flux is 2 into 10 to the power minus 2 and the number of conductors is 28. The armature the flux is 2 into 10 to the power minus 2. The number of conductors is 960. This number of conductors given as 960 into armature current is 28 ampere. Just now we calculated. Number of pole is 4 and number of parallel path also 4 because of lap connected. So, by simplifying this expression we got 85.4784 Newton meter. The torque developed in the armature, there is a total torque is 85.4784 Newton meter. Next we will go to the shaft torque. The torque developed in the armature is got some losses will be there. After the losses, the remaining will be available as a shaft torque. That is called the remaining torque will be available as shaft torque. Right. So, the shaft torque, the formula is output power divided by N into 9.55. So, we need a speed of the motor. The speed of the motor is not given. Right. So, we need to find the speed of the motor. In order to find the speed of the motor, we need a back EMF. So, first we will find back EMF, then speed, then we will go to the output power. From output power, we can able to find the shaft torque. So, first we will find the back EMF EB. For a shunt motor, it is EB equal to V minus IA RA. The formula is V equal to EB plus IA RA. From that, EB equal to V minus IA RA. So the voltage is 250 minus the armature current just now we calculated 28 ampere into the armature resistance is 0.12. So by simplifying this we got 246.4 voltage. So the back EMF equal to 246.4 voltage. Now the back EMF one more formula is P pi N divided by 60 into Z by A. Is very similar to the EMF induced in the generator. Here EMF is nothing but a back EMF. So by rearranging that is 60 and A is multiplied here, EB into 60 into A. Then P pi Z is multiplied in the denominator. So that we can able to find the expression for speed. N equal to EB into 60 into A divided by P into pi into Z. Now we will substitute the value one by one. The EB is nothing but 246.4 voltage. Just now we calculated. Then 60 into number of parallel path equal to 4 because of lap connected. Number of pole is given 4. The flux is 2 into 10 to the power minus 2 into the number of conductor is 960. So by simplifying this what we got 770 RPM. The speed of the motor is 770 RPM. Then we need one more parameter, say output power. We need output power. Then only we are able to find the shaft torque. So EB plus IA is equal to output power plus rotational losses. This input equal to output plus losses. That is a basic formula. The input given is converted into output power and some losses will be there. So by adding output power and losses, we can able to find the input power. So output power, so we can rearrange this. So output power equal to EBIA minus rotational losses. From input, if we subtract the rotational losses, we can able to find the output power. So this input power is available. EB is 246.4 voltage. Just now we calculated. Into IA is 26 ampere. And rotational losses is given in the problem, 825 watts. So by simplifying this we got 6074.2 watts. The output power equal to 6074.2 watts, right. So from input power by subtracting the losses we are able to find the output power. Now we got the value of output power and speed. So the shaft torque is nothing but TSH equal to 9.55 into output power divided by N. Now we calculated the output power and N also calculated, speed also calculated. So 9.55 into 6074.2 just is we are calculated divided by the speed 770 RPM, that also we calculated. So by simplifying this we got 75.34 Newton meter. So the torque available at the shaft is 75.34 Newton meter. The unit is Newton meter, right. So we calculated the shaft torque. So the armature torque what we calculated is 85.4784, right. So this the armature torque which is the torque available output is lesser, 85.85 around 85 Newton meter is developed torque developed in the armature, but only 75 is available at the output in the shaft end. So the remaining will be is nothing but the losses due to friction and windage losses. So in this problem we calculated the shaft torque as well as armature torque. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.